So question number 9 here. You are given that vector A is unit vector, so its magnitude must be 1, and vector A minus vector B dot vector A plus vector B equals to 12. This is also given to you. What you want to find? The question is, get the magnitude of this. This is the question here. Okay, so we just open this as we did twice. Vector A dot vector x, I'll write directly vector x the whole square, minus x bar vector x dot this here. What about this? And here, sorry, this will be plus, minus vector A dot vector x minus magnitude of vector A the whole square equals to 12. So these two are equal, you know, so therefore this will get cancelled. So we are getting this. I've used two concepts here, remember. One is dot product is commutative. One is this concept, remember. I'm just emphasizing. These two are equal, so it will get cancelled. And vector A dot vector A equals to magnitude of vector A the whole square. We already used twice, but one more time I'm telling you. Even this is like A plus B, A minus B, so A square minus B square, that property you can use. But when you have dot product with itself, remember it should be magnitude. If you write this is wrong, remember. If I write vector x whole square, this is wrong. Magnitude of the vector whole square, remember. Okay, now you know that this is 1. So here, this is equals to 1 equals to 12. And therefore, what we'll get finally? Yes, so magnitude of vector x equals to 13, and therefore root 13 if I take the square root. You cannot have plus or minus because magnitude of vector is always positive. So root 13 is your answer. Next question. Question number 10. Let me do that. 10th question here. What is given to you? You are given 3 vectors there. And show that this is perpendicular to such that, sorry, not show that, such that this is perpendicular to C, then find the lambda. So first you want vector A plus lambda vector B. आपको ये चाहिए. So let me add this two first. I'm adding this two. Component wise addition, remember. So what we'll get? You can see you have 2 minus lambda into I cap. Just notice, multiply b with lambda, remember, plus, what about the next one? 2 plus 2 lambda into j cap, plus here 3 plus lambda into k cap. I repeat, what I did, I've dropped one step, multiplying b with lambda and then I'm adding. So 2 minus lambda I cap, 2 plus 2 lambda j cap, 3 plus lambda k cap. This is 1. And vector C you have. What about vector C? That is 3 I cap plus j cap. Okay. And you are given this, that vector A plus lambda vector B is perpendicular to vector C. That's given to you. What's the meaning of this? The dot product of these two must be 0, remember. As I mentioned, two vectors are perpendicular if and only if the dot product is 0. So dot product of this with this must be 0. So now we are just multiplying these two, remember. How do we get the dot product? This into 3. 2 minus lambda into 3. Plus this into 1. So 2 plus 2 lambda into 1. Here 3, remember. Plus here what we have? 3 plus lambda into what's k term, that's not there, means coefficient is 0. Fine. So we'll get the 6 minus 3 lambda plus 2 lambda equals to 0. So here you will get 8 and lambda on the other side. So lambda equals to 8. The only important concept we have used is whenever vectors are orthogonal, then perpendicular, then the dot product is 0. How do we get the dot product? As I mentioned number of times, you multiply the corresponding, what you need to do? Multiply the corresponding components, remember. So this into 3, this one into 1, and here you can write like this if you want, 0 into k cap. So this into 0. So from this we'll get just lambda. Okay. Now what about next question, 11th? Show that this is perpendicular to this. So what do you need to show there? You just need to show that the dot product is 0. Remember, question number 11. Okay. Show that magnitude of A into vector B, this is like 2 into vector B, plus magnitude of B into vector A. We start with this dot product of the other one into vector B minus magnitude of vector B into vector A. We have started with dot product of these two, and we'll show that at the end that the dot product must be 0, remember. Okay, so I'll open as we did number of times. So you can write even directly also if you want, otherwise just open the bracket. So this one with this, here your dot product, remember. So magnitude of A, which is magnitude of A whole square, vector B dot vector B, which is B square magnitude. This with this, so here minus vector A with magnitude, vector B with magnitude, and here you have vector B dot vector A. This is like 2 and this is like 3, so 2 into 3 6, but B dot A will be there, remember. Now next we come to this, plus vector B with magnitude, vector A with magnitude, and here you have vector A dot product with this, minus, what about this, magnitude of B the whole square, this dot this, which is magnitude of A whole square. Fine. Distributive property indirectly. Why this is magnitude of whole square? Vector A dot vector A, which is magnitude of whole square. Now as I mentioned number of times, these two are equal, so ये दोनों cancel हो जाएंगे. Okay, and this two will get cancelled with this because these two are also equal, so this is 0. You have shown that the dot product is 0, therefore this plus vector magnitude of B vector A is perpendicular to this vector, right? That's proved. Just I've shown that dot product is 0, remember, with the help of properties, distributive properties effectively we are using. Question number 12, 12th question. What's the 12th question? Please read the question carefully. See, you are given that, what's given? A dot A equals to 0. That means magnitude of vector A whole square equals to 0. That means magnitude of vector equals to 0. Therefore, A must be null vector, remember, 0, 0, 0. This is the conclusion. This is the conclusion from the first information, remember. You are given this. From this, you have concluded that the vector A must be null vector, 0 vector. Fine. And you are given these also. vector A dot B equals to 0. Now this is always null vector as you have shown. This is always like 0, comma 0, comma 0, remember. So you can put anything here. The answer will be always 0. You can put 1, 2, 3, you can put 2, 3, 5 and so on. So it means the vector B can be any vector. Vector B can be any vector. Can be any vector, remember. You put anything there, it would be always 0. The product will be always 0. Fine. Vector B can be any vector. Why? I repeat one more time. See, from this, what I've shown that vector A is null vector. Now this is always null vector. So null vector dot anything always gives you 0. आप यहाँ पे कुछ भी रख सकते हैं, remember, instead of this. That means vector B can be any vector. Okay, question number 13, which is an important example here. 13 number, that's good example. What is given to you? Let me write that. You are given that these three vectors are unit vectors. So therefore their magnitude equals to 1. This is given to you. A, B and C are unit vectors satisfying this condition. Which condition? Such that their summation equals to 0 vector. Okay, and you want to get the value of that vector A dot B plus B dot C plus C dot A. You want that. That's the question. Okay. These two things you are given. Fine. Now what we'll do here, I'll take one vector on the other side. So vector A plus vector B, and then I'll take the modulus. So I'll get the modulus of vector C. Actually minus C, but that's not important. Actually you'll get the modulus of minus this, but that's same as this. Right? I did two things. One vector on the other side and then I took the modulus. Okay? Fine. If you want, you can write that intermediate step. Now I'll square it. Why I'll square it? Because the left hand side you can expand using A plus B whole square. So magnitude of A whole square plus magnitude of B the whole square plus 2 times vector A dot vector B equals to 1 here. Now these two are also 1. So 1 plus 2 times vector A dot vector B equals to 1. So what we'll get from this? Vector A dot vector B equals to, you will get a minus 1 and dividing by 2. So minus 1 by 2. Fine? Am I right? Now same way, again you can take 1 on the other side. Again, you can write like this. Suppose I'm taking now B on the other side. So vector A plus vector C equals to minus this. Now take the modulus. So vector A plus vector C equals to modulus of this. This is just vector. Now you square it. Expand like this. And therefore you will get the vector A dot vector C equals to minus 1 by 2. And now finally, again you can show that here vector B dot vector C, AB, here AC, and now BC is equals to again minus 1 by 2. Same way you can do. And therefore, if you add this, vector A plus A dot B plus B dot C plus C dot A equals to how much? Addition of this and this, which is nothing but the minus 3 by 2. Or if you don't want to do this way, you can do like this also, or let me show you. Alternatively, you can do like this. Start with the given expression equals to null vector. Take the modulus on both the sides. So modulus of null vector is 0, remember. Modulus of null vector is 0. Okay. Now I'll square it on both the sides. Normally, if you have any question of vector involving modulus, you square it. So square equals to 0. Now I'll expand the left hand side. I'll expand left hand side. This is like a plus b plus c whole square. So modulus of a whole square, modulus of b whole square, plus modulus of vector c whole square, plus 2 times vector a dot vector b, plus 2 times vector b dot vector c, plus 2 times vector c dot vector a equals to you have 0. This is like a plus b plus c whole square, a square plus b square plus c square plus 2ab, 2bc, 2ca. But here remember, when you expand with modulus, then for individual vectors you have magnitude, and when you are taking product, then you need to write dot product. Remember, keep in your mind. Okay, now this 1 1 1, this is given in the data, so this will be 3. Take 2 common, so vector a dot b plus b dot c plus c dot a equals to 0, and therefore finally you will get this. So what we'll get from this? Take 3 on the other side, 2 down. So this is another way of doing the same question if you want to do. Just have shown for you. Okay. Question number 14. What the question 14 says? Question 14 says that if either this or this is null vector, then the dot product is null, but the converse need not be true. So this is quite obvious. In 14th, so given that either A is null vector or B is null vector, right? So suppose A is null vector, then clearly if you write A dot B, that is vector 0 dot vector B, B need not be null, this will be always 0, because what are the components of this? 0 0 0, so it has to be 0. Or if vector B is null vector, then if you find the dot product, so vector A need not be null, but what about vector B? It is null vector, so this is again 0. So in this case you are through, right? If either A is null vector or B is null vector, then the dot product is always 0. Remember, the dot product is always 0. That's proved. So therefore what you have shown, if either A is null vector or B is null vector, then the dot product is always 0, right? This is proved. Now we want to show that converse need not be true. We want to show that converse need not be true. I must clarify here, remember at this place, remember here dot product and this is a vector, but answer will be here 0. This is not 0 vector. If you write here 0 vector on the right hand side, it's wrong, remember. Dot product of two vectors is a number, remember. Fine, it's like this. If I show you just for further clarification, ये जो है ऐसा हो रहा है. 0 vector means like this, 0 0 0 dot. यहाँ पे b में कुछ भी रखो, सपोज मैं b1 b2 b3 ले रहा हूँ, remember like this. Now get the dot product. What is dot product? 0 into b1 0 plus 0 into b2 0 plus 0 into b3 0, and therefore you are getting 0. That's what we have in our mind, remember. Dot product of 0 vector means 0 0. B can be anything, but 0 into b1 0 plus 0 into b2 0 plus 0 into b3 0. Therefore we are getting 0, and same thing here. So what you have concluded here, if at least one of the two vector is null vector, then dot product is 0. Converse, you can take two vectors by trial and error. What you have to do, you set the vectors in form of components. Suppose I'm writing 1, 2, 3 and b equals to, I have to select in such a way that the dot product must be 0. Remember, when you multiply the corresponding components, then this must be 0. That you have to keep in your mind. Okay, this should be here 0. Remember, that's what you have to do. So what I can do, suppose I'll put 2 here. So 1 into 2, 2. I can put here minus 1. So 2 into minus 1 minus 2 is 0 ho gaya. Now I can put 0. So 3 into 0, that's 0. Got it? Understood? So this is 0. So what you have shown here, the dot product is 0, but neither a null vector, a भी null नहीं है and b भी null नहीं है. Both of these are non-null vectors. You can find many such examples. If you want to write in IJK notation, you can write like this. You know this one. This is 2i cap minus j cap. Remember. Okay? You now must have realized how I said this. You can find many such examples. I've just taken one randomly, remember. So converse need not be true because of this by an example. Okay. Question number 15. What about question number 15? Question 15, you are given a triangle. The question is find the measure of angle ABC. So in the question it is given that ABC is the angle between vector BA and BC, remember. Okay. So this is also a good question. Let me just show you here. So you have a triangle here. Let me draw a triangle. This is ABC. You want these angles. So one is vector BC and the other one is vector BA, remember. You want this angle. This is the question. Fine? Okay. Now what are the position vectors here? This is given to you 1, 2, 3. This is given to you minus 1, 0, 0. And what about C? That is 0, 1, 2. This is given to you. Okay. I want vector BC and vector BA, remember. So here one is vector BA. You know how to do this position vector. A minus B, 1 minus 1, that is 2 here. 2 minus 0, which is 2, and 3 minus 0, which is 3. I repeat, vector BA. Do you remember beginning? How we did this vector BA? BA minus B reverse. 1 minus 1, so this is 2. 2 minus 0, which is 2, and 3 minus 0, which is 3. Okay, what about the other vector? That is BC. C minus B. 0 minus minus 1, which is 1. 1 minus 0, which is 1. And 2 minus 0, which is 2. You got these two vectors. So ultimately, this angle, if I call the theta, that is angle between these two vectors, remember. These two vectors. Which two vectors? BA and BC. So therefore, cosine theta, which is nothing but the cosine, which angle? ABC. That's what you are asked. Which is equals to, how do we get the angle between two vectors? Their dot product. So BA dot BC upon their magnitude. Upon their magnitude. Fine? We have used that formula. Which formula? Vector A dot vector B. Vector A dot vector B upon their magnitude. Magnitude of vector A, magnitude of vector B, remember. That's what you have used indirectly. Is it? Now, just you need to simplify, so you'll get the required angle. Okay, dot product of these two. Right? So let me write here dot product. What's the dot product here? 2 into 1, you know 2. 2 into 1 plus 2 plus 6. this into this plus this into this plus this into this upon the magnitude of the first one. What is that? 9 plus 4 plus 4. 9 plus 4 plus 4, that is nothing but root 17 into BC. 4 plus 1 plus 1, that is root 6. Okay, so what we'll get finally? 10 upon here, this the product of these two, which is nothing but here, it is 102 root of 17 into this, and therefore finally theta equals to cos inverse, we'll get the 10 upon root 102. That is your answer, right? Angle between these two vectors, these and this, and that is nothing but this angle, remember, theta. Okay, question number 16, show that these points are collinear. Okay, so we had such questions in 11th also. So in the next question number 16, you are given 1a here, 1 2 7, you are given b here 2 6 3, and c here, that is 3 10 minus 1. Now there are a number of ways. One, you can use distance formula. Use distance formula. You did such things in 11th if you remember. Get the magnitude of vector AB. You know how to get this. How do we get the position vector of AB? You know. Get the magnitude of vector BC. Get the magnitude of vector AC or CA, right? Get this, and get this. You will notice that sum of any two must be third one. Sum of any two equals to third one, third measure. Third, therefore points are collinear. Points are collinear. Or the another way of doing the same thing, get the vector AB and vector BC. You will see that one must be multiple of the other one for some scalar k, for k, remember. That means these two vectors are in same or opposite direction. This is another way. Try yourselves. This is for you. Do it. This is straightforward distance formula, right? Not a big task for us. Remember, you can do it. Or you just notice vector AB and BC. If you find this, one must be multiple of the other, maybe negative or positive. Multiple of the other one means what? Either their vectors are in the same or opposite direction. That means points are collinear. Question number 17. Show that this vectors forms the vertices of a right angle triangle. Okay, so let me take here vertex A as 2i cap minus j cap plus k cap. Vertex B as I cap minus 3j minus 5k. And vertex C as 3i cap minus 4j minus 4k, right? We had earlier such question about vertices of a right angle triangle. Just refer, you will realize, refer question number 17 of 10.2. And you can refer the example number 12. Example 12. Both were about right angle triangle, right? We have used Pythagoras theorem there. But here I'll do using the concept of perpendicular vectors, you will see. So this is a triangle, for example, like this, right? We don't know what's the labeling. So we find three side vectors, for example, AB, BC and AC. So sides are this, vector AB, let's get this, vector BC. You can write AC or CA, that's not important. Okay. Chalo, now vector AB. side vectors AB, BC and AC. AB means B minus A. This minus I cap. Just have a look there. This minus 2J. This minus this minus I cap. Minus 3 plus 1 2J. This minus 6 cap. Chalo BC. What about BC? C minus B. 2I cap. This minus this, just minus J cap. This minus this plus K cap. And AC means C minus A. This minus this, that is I cap. This minus this, that is nothing but what? Minus 3J cap. And this minus this, which is nothing but the minus 5K. Okay, now if you observe these three side vectors carefully, you will find that out of these three, 2 must have dot product equals to 0. So this is just by observation. I suppose if I take the dot product of these two, vector BC dot vector AC, see the dot product of these two. I'm just doing dot product. So what I'll get? 2 into 1, which is 2, plus minus 1 into minus 3, that's 3, plus 1 into minus 5, that's minus 5. So what is this? This is 0. So what you have noticed here? These two vectors are orthogonal, right? So BC must be perpendicular to vector AC. Therefore, measure of angle C must be 90 degree here. C is common, remember. And therefore, triangle is right angle. Triangle is right angle. That's what proved. So here you have used the concept of dot product, remember. C must be like this here. Then you have here suppose A and here you have B like this. So you take the vector BC. One is this vector. The other one AC. These two are orthogonal. So this is 90 degree. Fine. You just go through these two examples. This one and this one. There we have not used this concept. We have used the concept of what? Distance. We have obtained these magnitudes and we have used indirectly Pythagoras theorem. Here what I did, I've used the concept of orthogonal vectors, perpendicular vectors. Dot product equals to 0, therefore vectors must be perpendicular. Fine. Let's see the last question MCQ. You are given a vector A with magnitude equals to small a. This is given, remember. Magnitude of vector A equals to small a. Lambda is a scalar number which is not 0, right? And this is a unit vector, is unit vector, that's given to you. It means its magnitude must be 1. So magnitude of this equals to 1. Now you can apply individual modulus here, equals to 1. But this is A, you know. So modulus of lambda, this is A equals to 1, and therefore what is A, which is 1 upon modulus of lambda, right? This is nothing but, you know, option D. So this is unit vector, therefore this. So this become unit vector if A equals to 1 upon modulus of lambda. Lambda is a scalar, so you cannot drop the modulus.